Hello guys, how are you today? So today I'll be explaining the chapter 8 for chemistry. This is level and material. So, uh, chapter 8 summary. This is for chemistry, okay? So in chapter 8 we don't have a lot to discuss. It's mainly about bonds, the types of bonds and how we denote them and whatever. So first we're gonna start with a quick summary of bonds, okay? So we have a chemical bond. What is a chemical bond? So a chemical bond is the force, okay? It is the force that holds atoms and makes them function as one unit. So chemical bond is the force that holds atoms and makes them function as one unit. Meaning, an example, like a very famous compound is NaCl. It's an ionic compound and it is held by a type of chemical bond which is called an ionic bond. Okay? Or for example HCl, which is a covalent bonding, but no, it is still like a chemical bond. Now, there is something else about bonds is that they each have a length. So the bond length, it is the distance between the nuclei of two bonded atoms. So the distance between the nuclei of two bonded atoms. Alright, so now we move on to discussing the types of bonds. We have two major types of bonds. So I'm just gonna write bonds. We have two major types, which are covalent bonds and then ionic bonds. So covalent bonds, they are shared electrons. They are bonds that are formed by shared electrons between usually two non-metals, okay? And covalent can be split into many groups. So it can be a single covalent or double covalent or even triple covalent, okay? Whereas for ionic, okay, ionic is the transfer of electrons, or it is the force of transferred electrons between a metal and a non-metal. Now, usually in ionic bondings, we have two things. They are called cations and anions. As you guys know from before, that cations are the positive ions and they are usually metals, whereas anions are the negative ions and they are usually non-metals. So now, after a quick discussion of bonds and everything, we move on to something called electronic representation. Okay, now what about electronic representation? Alright, so we can deal with two types, or not two types. To be more specific, I'm gonna say three types because the second one can be split into two. So we have three types of electronic representation. The first one is for a single atom or element. This is one. The second one is for ions, which are cations and ions. And then the third one is for compounds. Now, what about these dative representations? Oh, sorry, not dative, my bad, electronic representations. I was thinking of something else. So, let us take any atom or element. I'm gonna take two atoms or like two elements. So we can take Na, which has an atomic number of 11, and let us take F, which has an atomic number of 9. So we are going to represent an A by itself and F by itself. First thing we're going to do is we're going to do their electronic configurations. So I think by now we all know how to do their electronic configurations. It's either by the SPDF okay? Or the electronic configuration, which is like 2882, or if you're dealing with the really big ones, it can be 2, 8, 18, 18, 18, 18, and etc. Okay? Okay, so if we do the electronic configuration of an A, it is gonna be 2, 8, 1. Okay, for F, it is then gonna be 2 and 7. Now, we have many ways to denote an A, so you could either denote it like this, an A, alright, and you take the number of valence electrons, which is 1, and you're gonna put it, for example. For F, you are gonna do the same thing, but you're gonna put 1, 2, sorry, we're not gonna go like this. We're gonna go in the direction of the compass. So we have north, east, south, west. So we're gonna follow. So first north, then east, then south, then west. Now we finished how much? We finished 4. So we need to complete the rest. So we're gonna do another rotation. So again, north, east, south, and then like this you have 7. And you are missing 1. Now what happens over here, we call this a lone pair. So if 2 are already together in an element or compound or ion or whatever, we call this a lone pair. However, if it's sharing or it's taking or whatever, or it's, all of these things, transferring, then we call this either an ionic bond, a covalent bond, or just in general a chemical bond. Okay, this is the first way to represent it. The second way is by the cloud. So you can either represent it with all of its clouds. So for Na it's gonna be 2. Then we have another one which is 8. So 1. Here's 1, 2, 3, 4, 5, 6, 7, and 8. So like this we finished 8. Then we have one more surrounding which has the single valence electron. Okay, so if we do the same thing with F, it's gonna be F with a surrounding shell which is 1, 2. Then we will do another shell, and this has the remaining 7. So it's 1, 2, 3, 4, 5, 6, and 7. So now let us discuss about ions. Okay, so we're gonna take the same examples again, which is Na, okay, and F. But here we're not gonna be discussing them as elements or atoms. No, we're gonna be discussing them as ions. So Na plus and F minus. So what is happening when it's becoming an ion is it's losing an electron or it is gaining an electron, okay? So let's say we're gonna go back up to the diagrams drawn about Na and F, and let's say Na lost an electron. So let's say it's gonna lose definitely the first one in the outer shell. This one is gonna go, okay? As you can see, it would have completed the electric configuration of what? Of a noble gas, because it will have 8 electrons only in its valence shell. Whereas originally, this was its valence shell. It lost this electron, okay? And then it's going to be left with 8 electrons in its valence shell, meaning Na plus has achieved the configuration of noble gases. And so if we want to denote it, we will either denote it like this, but without the last valence shell, so like Na, 1, 2, then another one, 1, 2, 3, 4, 5, 6, 7, 8. So this is how we represent it. Okay, but here there is some kind of issue because we have to put a bracket with the charge, so Na plus. So this is one way of representing it. Another way of representing it is that we only draw the valence electron, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and then we put this with a plus, or very simply, because it's a cation, pay attention, only because it is a cation, we can remove the valence electrons and we will have a plus. However, if we are dealing with F minus, so let's say it gained an electron, okay, so it will gain it here, it would have also achieved the electric configuration of a noble gas, so it has 8 electrons in its valence shell. So we can denote it either like this. So F 1, 2, 1, 2. Oops. Sorry, I don't know what I did. So 1, 2, 3, 4, 5, 6, 7. But here we are gonna put 8, a different form, because this electron is not from the F, it's from another element. So it gained an electron from another element. Okay, and this is why we will denote it like this, and we're gonna put a minus. Now the second way, which is the last way to denote it, is to put F, and then we're gonna put 1, 2, 3, 4, 5, 6, and then 7, 8, okay, and we will put minus. We cannot denote it like this. Why? Because it has an electron that does not belong to it. However, if it has all electrons that belong to it and it achieved the configuration of a noble gas, then you can represent it like this. Okay, that is it for ions. So we move on to the next topic, which is compounds, I believe. What did I write? Yeah, compounds. So topic 3 is compounds. So let me write a bunch of compounds. We have ionic compound NaCl, or we have compound H2 gas, or H2O, and I'm gonna take one more ionic, so we could take KBr. So these are all examples of compounds. Now, how do we denote compounds? The first thing is we need to identify, are they ionic or covalent? This is ionic, this is covalent, this is also ionic, and this is also covalent. Okay, so NaCl, let us start with NaCl. So first thing, we know it is ionic. So when it is ionic, okay, what we're gonna do is we're gonna represent it like this. And now I'm gonna show you the difference between ionic bonds, okay, and covalent bonds represented by the electric or electron representation of atoms, or electronic representation, okay? So as we said, Na and Cl, they are ionic, so we split them into their ions, which is Na plus and Cl minus. Now Na, we can write it like this, Na plus. However, Cl minus, since it's gaining an electron, and this electron does not belong to Cl, so we have to denote it like this. So Cl, we know that Cl has an atomic number of 17, so its electronic configuration is 287. So it's gonna have 1, 2, 3, 4, 5, 6, and 7, and then 1 that doesn't belong to it. And we do not forget to put the charge, which is minus. Now this is how we represent ionic bonds. So let me do now covalent. H2O is a covalent bond. Now covalent bond means that they share electrons. Okay? Whereas ionic bonds mean they are sharing, they are transferring electron. So the Na removed one of its electrons to give it to the Cl minus, because Na was originally 11, so it was 2, 8, 1. So to remove this one, gave it to the 7 over here. So now this has an electronic configuration of 2, 8, and this has 2, 8, 8. So yeah, this is what it means to be ionic. Whereas the covalent, for example, H2O, we are gonna have H over here, O in the middle, and H over here, just an example, okay? Now we are gonna draw intersections because we know it is what it is, covalent. So let me just draw it a bit better. So since it is covalent, we are gonna be drawing some intersections. So the red is gonna be for O. Okay, I will just write it on top. And then the green is gonna be for the H's, okay? So now we know for H, its electronic configuration is, it is 1. So that means it has 1 electron. So both H's both have 1 electron. Whereas O, we know it has an atomic number of 8, so its electronic configuration is 2, 6. So it's gonna be 1, 2, 3, 4, 5, and then 6. Notice why I put it down. Now you will see why I put it down. And then 1. So this has 1 over here and 1 over here. So as you can see, okay, in the intersections, we have some electrons that are shared. So the H is sharing one electron with O, and the O is sharing another electron with H. Same thing, O is sharing one with H is sharing one with O. So we could denote it like this. Or another way we could denote it is that H has like this, the H has one like this. Then O has 6, so 1, 2, 3. Don't do like that, sorry. Start always cardinal direction. So 1, 2, 3, 4, 5, and 6. So these will share, they will create a bond, and that is how H2O is formed. Alright, now some of you may be confused and ask why, like, you have electrons not bonded to anything, why doesn't it have a charge? Well, very simply because these are, again, as we said before, lone pairs. So lone pairs do not have a charge. Okay, they would have already be sharing or being paired with another electron. So, we did H2O and an ACL, one ionic and one covalent. Now H2 and KBr, okay, I'm gonna do H2. So we know H has one electron and another H has another electron. So they're gonna share it. It's gonna be either like this, or however you represent it. Or if you want to do the intersection, it's gonna be like this. Then the other one that we have is KBr. Since it's ionic, we can represent K like this. K is gonna be minus. And then Br, we know it has an electronic configuration, 35 is its atomic number. So if we are to do its electronic configuration, so you can do it from the SPDF way or from the 2, 8, 18, 18, 18, 18, etc. way. So either way, you are gonna get that it has 1. This is plus, by the way, I apologize, not minus, it's plus. So 1 valence electron, okay? Or very simply, you could know its charge to be is Br minus. So what's gonna happen now? Alright, but here is where we come and we see, okay, K has all of its electrons that belong to it, whereas Br does not have all of its electrons that belong to it. So Br, if we do its electronic configuration, so it has 7 valence electrons, okay? So we're gonna have 1, 2, 3, 4 following cardinal directions, then 5, 6, 7. However, for the 8th, it's gonna take a different form because it's not an electron of Br minus, okay? Now the last topic we will discuss about in chapter 8 is called dative or coordinate covalent bonds. Okay? So what about these dative coordinate bonds is that we have 2 definitions for them. The most common one is that there are 2 electrons coming from the same element in a bond, okay? Or that very simply one bond is not the same as the rest. Okay, but the one they want us to use in the book is that 2 electrons coming from the same element in a bond. And we are talking about which type of bond? We are talking about covalent bonds. So I'm gonna give you one example, okay, which is NH4+. This is an example of a dative coordinate covalent bond. Okay, so we know that N is what? N has an electronic configuration of 2, 5. And H has an electronic configuration of 1. So if we're going to draw it, we're going to have N over here. And don't forget, this is always covalent. So, okay? So if we are to represent it, we're going to have N that has 5. So 1, 2, 3, 4, and 5. Okay? Then we have H. So we have 4 H's. So H here, H here, H here, and H here. And H shares 1 electron. So as you can see over here, that 2 electrons are given from the N to the H. So this is called a dative bond. Now, the most important things you need to remember, okay, or the most important dative bonds that you need to remember are NH4 plus, H3O plus, NH3BF, BF, that's it, and BF4 minus. So these four, you remember them? They are dative bonds. The rest that they might bring in the exam, they're not going to be dative bonds. So that's it for chapter 8. Thank you guys for watching. I hope you enjoyed and have a wonderful day.